Alright, muchachos, so there's a problem, and that problem is that there's more information in our world, more than there are data types in programming, right? There's only 3 data types: strings, numbers, or booleans, and in Racket's case, images, but let's just ignore that for now, and let's just say there are 3, alright? So we have more information than we do have data types, therefore we have to sort of represent information as data, right? And interpret that data back out as information, all right? So for example, the color red. A computer doesn't know what red is. It doesn't have the biology of color receptors and eyes. So say you're making a program that simulates traffic lights, right? You have a red light, a green light, and a yellow light, right? Well, we have to represent that in the world of data. So we have to pick one of these. In this case, we'll pick numbers, a structure of numbers, right? 255000255. And if this looks familiar, it is the RGBA standard. All right, red, green, blue, and alpha. Each one of these contributes its value to the resulting color. And Racket does have support for this. All right, so for the rectangle function, we provide the string red. What we can also do is provide the color structure. All right, so let me just write this down. So color 255000255, right? Contribute more red, green, blue, alpha. So that's the same color, but we can vary this more easily. So 155. That's a darker rose red, all right? And yeah, all right, so let's just go back to this. All right, and we have to interpret this as information. And so we do visually, right? What about, something like attack damage in a video game? Say you're making a video game and you want, some swords to do more damage than another. Well, that's best represented by numbers. And then we have to interpret that back out as information. And what about the age of a human, right? Well, we have to pick something. So we'll pick numbers in the world of data, right? And we'll say that it's between 0 and 100, just to constrain and be more specific. And we have to interpret this number back out as information, right? Information being time in Earth, right? Because other planets have probably different scales of time, right? So what about if you're making a program that, considers if someone's married, right? Keeps track of that. And that we can use a Boolean for that, right? You're either married or you're not. And that can be represented with a Boolean. But that Boolean has to be, you have to remind yourself, and it has to be interpreted as information. Usernames are best represented as strings, right? And then that string has to be interpreted as information. So in light of the problem that there's more information than there is data in a given programming language, we'll say there's only 3 for now, we have adjusted the design recipe to help you design data, all right? So this is the new updated design recipe. We've added these 3 steps. In this one, just comes from the how to design function step. We just shifted that up, all right? Anywho, let's apply this to a problem that we've done before. So canRide, all right? So canRide is a function that consumes a number and a Boolean and produces a Boolean, all right? But we can be more precise about this number. This number is an age, but ages can't be negative. It doesn't make sense to have a negative age. What does it mean that you're negative 55? Well, I guess it means that, that you're not born yet. But anywho, we can be more specific about what this data consumes and more precise. All right, so let's just go through the how to design data steps. So data description. So we're going to describe what an age is. So instead of canRide consuming a number, we're going to say it consumes an age. Therefore, we have to write what an age is. So age is a number, a natural number, so non-negative, from the ranges of 0 to 100 inclusive. All right, these square braces means we're going to include 0 through 100. So that's the data definition done. Data description done. Oh, there we go. Next is the interpretation. All right, so interpretation. We'll just write interp for short. And this age, sometimes it's redundant to write interpretations. But, in this case, I'm going to practice being as verbose as possible. We're going to really describe the data that we're trying to represent, right? The information that we're trying to represent. And this will help us scope out what and how to write the function, all right? So in interpretation, we'll say age in human Earth years. All right, because in dog years, right? Dogs have, I don't know. Once a dog is like 18, it's like they're like really old or something. But anyways, let's say like what happens if we have humans on Mars, and there are some Mars programmers, and of course on Mars years are calculated differently, right? A year is how much a human year is defined as how the Earth revolves around the sun, and how long it takes to do one full cycle, right? But Mars, I forgot if it's like faster or slower. But anyways, there's a difference, and of course I want to describe this difference, because if I'm programming on Mars, it's probably not going to be 12 that you can ride a carnival ride on Mars, because Mars has a different measurement of an age in time, right? So we'll do this interpretation here. All right, so there we go. Next is data examples. So this is of course kind of boring because the data is kind of boring. But in the upcoming videos, we'll go over more interesting and more complex examples of data examples. So let's do AG13 is 13. Define AG18 is 18. All right. Again, we'll see more interesting examples in the future. All right. But just to note that this is going to help you, really understand and run through your head, run through not only your head, but a physical motion, just like how, the examples in functions really help you jot down and run through the processes that describe what the function is supposed to do. This does the same for data, right? All right, so that's data examples done. We're going to do the template. All right, so let me just mark myself done for that. Let's just do the template really quickly. So define, call it age temp, right? Temp short for a template, consumes an age, and of course we got to do something to that age. All right, and that is how to design data. But let me make one last important note here, and that is because this is a comment, right? You guys might get smart and go, all right, it's just a comment. I can probably hold this in my head. I don't really care to write this comment. I'll just, short skip it. But again, we're going to go through really, really complex problems. And if you don't do this, you're going to struggle in the later sections, because writing all this down really helps some parts of your brain that will help solve a problem. All right. So you're going to lose a lot of value if you don't do all these steps. All right. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.